Alright, so here we are. Welcome back to another series of Just the Maths. And in this particular series, we're going to talk about algebra. So this is our 14th lesson. So, like, if you're a student struggling with logarithms or just someone who wants to understand logarithms, and you're in the right video because today we are going to dive logarithms in general. We're gonna talk what they are, how they work, and they are more important than you might think. So like stick around until the end for a lesson. And yeah, so let's go. So before we start, let's talk about uh-huh. Let's talk about let's have a review. We have here an additional review. So let's start simple. Let's say you have 10 squared is equal to 100. So then the logarithm is just like is just like the reverse question. Like for example, like what power of 10 gives 100? That means the answer is 2. That's because 10 squared is equal to 100. So when we're looking for the power, we log as log base 10 of 100 is equal to 2. So like here, ask this question, what exponent should I put on 10 to make it 100? Like, so in math language, that's log base 10 of 100 is equal to 2. So like think of logarithms like the opposite of exponents. So let's have um a review. One second. Let's have a review first. In general, when it occurs that x is equal to some base 10, that's raised to y. So when we have a base of 10, so that's what we call a common logarithm. So when we say a common logarithm, that's a logarithm of base 10. Okay, but that's another topic on our last video. So if you want to check that, check it. We have more information about it on that. But in this lesson, we're going to talk about logarithms in general. So we're going to talk its definition. So logarithms is not just only on base 10. It can have a different base which is more common. So not everything is about base 10. Like we can use any positive number as a base as long as it's not one as stated here. If b is a positive, if it's a fixed positive number and x is another positive number, such that x is equal to b raised to y, we say that y is the logarithm to base b of x, and we write y is equal to log base b of x. So if x equals b is equal to the power of y, then y is the logarithm of x to the base b. So log base b of x equals y. So like it's like you're asking yourself like what power must I raise b to get x? So to further understand this topic, let's have some examples. Some basic examples. When we have log base b of 1 is equal to 0. That's because any and like if you have any base but beside on the base is equal to 1, that's always equal to 0 because any number raised to 0 is 1, right? So I don't think these really are examples, but like these are like the rules that you need some tips, you know. So second example or tip. So when we have log base b raised to the same number b, that's equal to 1 because n any um any when we raise something into 1 is just the same as it is, right? Because yeah. So but log b of 0 is undefined. It doesn't really exist because no power of b can be equal to 0. There's no such exponent that turns a positive basis that is equal to 0. So like just remember this. Logarithms only work with positive numbers. There's no such thing as a log of a negative number or 0, not in the world of real numbers. But some, it shows that log base b of 0 is equal to negative infinity. And that's it on our lesson actually. It's a very short lesson. We're going to talk more about logarithms soon. But like let's let's have the purpose. What is the purpose of a logarithm? So the purpose of a logarithm um, it shows in science, in engineering, and even your smartphone. I'm just wasting our time here because we still have a lot of time. So like like sound levels, it works with logarithms, like it's logarithmic. You know, earthquake intensity, that's also logarithmic. Like it helps us take really big numbers and scale them into something manageable. All right. So like it's like for example, it's like zooming out from a mountain. Like for example, you're in a mountain, and then you zoom out to get its full view. Like it helps us understand massive quantities in a much simpler way. So let's dive something deeper, like learning mathematics, learning logarithms. For example, if you're learning logarithms, it teaches us more than solving equations. You know, when you solve, sometimes you get frustrated. Like it's just testing your patience. It teaches patience. It teaches us how to reverse a problem and look at it on another angle, like what we have in here in this slide. Like no, it's like you're reversing what is the answer of the exponent of a number with a base 10 and an exponent of 2. It has 100. And if you're looking for exponent, what exponent should I put on 10 to make it 100? It's like you're like just reversing it, right? And yeah, so just like in life, when it seemed complicated, just take a step back and like ask yourself a different question. Like approach that problem differently. Like, sometimes all you need is a different perspective. And suddenly, what felt impossible starts to make sense. So I hope that this video helped you a little. Give it a thumbs up. Share it with a friend who's scared of logs, scared of logarithms. But logs, not that kind of log in a forest, but no, logarithms, mathematics, you know. So yeah. So that's it. So like Learning takes time. Growth isn't instant, but you'll get closer to mastery really soon. Keep going. You got this. Thank you for watching, and thank you so much for your attention.